Hi, everybody. Happy Monday and welcome to a new chapter. So, we have officially finished chapter 8, which was all about factoring. And in this chapter, chapter 9, you're going to be using a lot of those factoring skills within quadratic equations. So, I'm just telling you right now, buckle up. It's nothing that's crazy complicated in chapter 9. It's just so much new information. So, guys, I'm not gonna lie, I put my hair up to teach you guys this lesson because I was like, okay, it's time. We're starting chapter 9. Like, let's go. So, this is something where you're definitely going to want your notebook out. We're going to combine lessons 9.1 and 9.2 together for two reasons. Number one, you know a lot of the foundational information. And number two, I am running out of days with you guys. So, I have selected the most important algebra lessons to teach you before you leave and graduate. So, here we go. We are starting lessons 9.1 and 9.2. It is about quadratic graphs in quadratic functions. And it might sound abstract right now, but as soon as I show it to you, you'll know what I'm talking about. So here are your objectives for today, and these are important. Number one, I can write an equation for an axis of symmetry. Number two, I can graph a quadratic equation. Number three, I can order parabolas from widest to narrowest. So let's go ahead and jump right in. And if you have your notebooks, this is where you're going to want to start, recording what I'm talking about here and sketching graphs alongside me. Okay, if I asked you what a quadratic function is, these are examples. Do you remember what these are called when you've got kind of the U with the line here? When we think quadratic functions, we think parabolas. These are called parabolas, and let me spell that out for you. Okay, so it's called a parabola. For an equation to be quadratic or a function to be quadratic, notice that it has an exponent of 2 by x here. Okay, so this would be y equals x squared. This would be y equals negative x squared plus 4x. It has to have that exponent of 2. And I bet that you can already start drawing conclusions about quadratic functions. Look here, if this opens upward and the equation is y equals x squared, compared to this guy over here that opens downward, and this is y equals negative x squared. So can you start to draw conclusions baseline? If it opens up, your leading coefficient here will be positive. Okay, this is technically a positive 1. And if it opens downward, this will have a negative leading coefficient. Okay, so that I have some notes on this for you, so you don't need to sketch it down yet. So here we go. Your vertex is the highest or lowest point of a parabola. So if I showed you these guys again, your vertex would be right here. This is your lowest point, and your vertex would be right here. This is your highest point. The basic form of a quadratic function is ax squared plus bx plus c. You might see this as, hold on one second. You might see this as y equals, or you could see it as f of x equals. It's the same thing, but this is the most basic form of a quadratic function. Ax squared, emphasis on the x squared, plus bx plus c. If a is greater than 0, meaning that it is positive, that means that your parabola will open upward and the vertex will be a minimum. Okay, let me show you that. So notice that a is positive because it's a positive 1 here. Your parabola opens upward, and the vertex of the graph, which is right here, would technically be the lowest point. Okay? However, on the other side, if a is less than 0, meaning that a is negative, your parabola will open downward, and because it's downward, the vertex will be the maximum point. Okay, so let's look at this side by side, and you're going to want to start taking notes and sketching this down. So in this graph, a is greater than 0, which means it's positive because this opens upward. Therefore, your vertex is at the bottom, and it's like the minimum point. Over here, if a is less than 0, meaning that it's negative, it's going to open downwards, and your vertex will be the maximum point. Let's look at that again. And I'm showing this to you so many times because it's so important. Because this guy opens upward, okay, a is greater than 0, it's positive, it would be 1 down here, and your vertex is the minimum. Over here, because it opens downward, you know that a will be negative. Your leading coefficient will be negative, as you can see by -1, and your vertex is the maximum. So now, with that information, what statements can you make about this graph here, about this parabola? And if you want to pause and think about it before I show you, that would be a good idea. Okay, so here's how it goes in my head. If I asked you what statements you can make about this parabola, number one, you'd say it is a parabola. It is a quadratic function, and you know that because it made a parabola. Only quadratic functions do that. The vertex is a maximum because it is your highest point. Vertex is a maximum. That's right there. That's your highest point. Because it opens downward, we know that A, our leading coefficient, is negative. So that's all that you can tell me from the graph. You will, as the lesson goes on, you'll be able to tell me the equation for the axis of symmetry as well. Axis of symmetry is the line that cuts your graph exactly in half. All right, so now another skill that you can master from this lesson is when we're talking about parabolas in their width, meaning like how closed, how open they are. If you're looking at these three parabolas here, what can you conclude based on the leading coefficient and the widths of the parabola? So like this graph has a leading coefficient of -4. This one that's very open is 1/4. And this one that's like right in the middle has a coefficient of 1. So when we're looking at the widths of the parabolas, I'm like, okay, so this is a -4, this is 1/4, and this is 1. So the widest is technically the smallest number, absolute value, and the narrowest is technically the largest number in terms of absolute value. And that is what we can conclude. The greater the absolute value of A, it doesn't matter if it's positive or negative, the narrower the parabola would be. So if you look, the greatest number with absolute value is this guy here with a -4. And look how narrow that is. Whereas the smallest number, this 1/4 here, is the widest. Let's practice that together. All right, so can you order the blue, the green, and the red in order from the widest to the narrowest? The widest means that your number will be the smallest, and the narrowest means that your number in absolute value will be the biggest. So if I'm looking here at, I've got a -6, I've got a -1/2, and I've got a 2. So if we're starting with the widest, that means we need our smallest number, which I know it's going to be this -1/2. Then the next smallest will be 2, and then the largest will be a -6. Because remember, we're talking about absolute value. Doesn't matter if it's negative. And if I sketch this for you, just so you have like a better picture and you really get that understanding. Okay, so first of all, it's negative, so it'll be opening downward, and it's a -1/2, so it'll be pretty wide. So it's going to look something like this. If it's y equals 2x squared, 2 is positive, so it'll be opening upward, and it'll be more narrow. Okay, it'll be more narrow than my black one. And then because this is a -6, it'll be opening downward, and it'll be very narrow. Oops, that was even way too wide. So it will be very, very narrow, very tight together. So the smaller the absolute value with the number, the wider the parabola. The greater the absolute value, the narrower. Okay, I know it seems like it's the opposite, but welcome to math. Welcome to algebra. All right, so now if you're looking, all right, let's say that we're looking at y equals 2x squared plus 3. Okay, that's my blue graph here. And just y equals 2x squared. Can you tell the difference between those two equations? Can you tell the only difference between them? I know that their width stayed the same. Okay, the width of the parabolas for these two equations stayed the same because you've got 2 and you've got 2. The only difference, you guys, between these two graphs is that the blue one was shifted up 3 units. And you can tell that because it's adding 3, and it's 3 more in this chart here. So I just wanted to expose you to that because sometimes you might have to compare 2 different quadratic equations. And if you're looking at 2x squared versus 2x squared plus 3, the 2x squared plus 3 is just shifted up 3 units. That's a very quick, very easy. Okay, another thing that you need to get some exposure to is real-world situations and quadratic graphs. So if I dropped a fish stick from a tree 20 feet high, here's an equation to model that situation. And for the record, I do not like fish sticks at all. Okay, so it's h equals -16t squared plus 20. This 20 here, that is used to model the starting height of the fish stick in the tree. So that would be like maybe something like, I don't know, like right here. That's where the fish stick is starting. That's the starting height. Now, it is a negative, okay, negative leading coefficient because it's going to be going down. Think about it, you're throwing a fish stick out of a tree. It's going down, okay? And it would look something like this. Now, kids always get confused and they're like, why would it end right here? But if you think about it, like, can a fish stick go through the ground? Well, no, because this isn't Fantasyland. So you're starting at a tree in 20 feet, throw it down, okay, it stops at the ground. And I know it seems like very random that I'm throwing this in here, but I just wanted to make sure that you saw like how some real world situations can be represented by a quadratic function. And that's really all that you need to work on for there. All right, moving on. This will be something that comes into play in geometry as well. I am talking about an axis of symmetry. That was supposed to be a highlighter, not crossing it off in green pen. Yikes. An axis of symmetry is a line that cuts your parabola exactly in half so that if you folded it together, it would be exactly the same on both sides. And you can see like you've got 1, 2, and you've got 1, 2. So your axis of symmetry is a line that goes down your parabola that not only cuts through your vertex, but it cuts your parabola in half. If I asked you to write the equation for this axis of symmetry that's right here, what would you tell me? What would be the equation of this vertical red line? Well, because it's vertical, it's going to be x equals, and it runs through 3. So the equation for this axis of symmetry is x equals 3. Now, it's not always going to be that easy just to draw a line and write the equation for it. There's actually a formula. When you're graphing the equation, okay, in the form of ax squared plus bx plus c, that's your basic quadratic function equation. The formula for an axis of symmetry looks like this. X equals negative b over 2a. Okay, you're going to have to write that down. So if you don't have a pencil in your notebook, write it down right now. So for your line of symmetry, to find it, if you're just given a quadratic equation, it's x equals negative b over 2a. So let's say that you're given the following quadratic equation. Help me find the equation for the axis of symmetry. So I've got y equals x squared plus 12x plus 32. The first thing you want to do is write out for yourself, all right, a equals this, b equals this, c equals this. We know a is 1, we know b is 12, and we know c is 32. The equation for the axis of symmetry is x equals negative b over 2a. It's just like a formula, you guys. You just plug in the values. So we know b is 12, so you're going to plug that in here. Notice that it retains that negative, okay? And then if a equals 1, we know 2 times a will be 2 times 1. Negative 12 divided by 2 is negative 6. That means the equation for my line of symmetry is x equals negative 6. And that's it, you guys. So when you're given a quadratic equation, you can find the equation for the axis of symmetry using the formula x equals negative b over 2a. Okay, and that's what you've got there. Now it is time for potential brain explosions, but hopefully not, okay, if you follow my easy steps. If I asked you to graph this equation, y equals 1/2 x squared, you could easily do that by filling in an xy chart. Like you plug in all these values for x, you get your y, and you plot those coordinate pairs. Now I'm going to teach you how to do it the algebraic way. Here are your steps for graphing a quadratic equation. Okay, it's a lot of information, so I'm going to go through it with you. You're going to write it down, and then we're going to practice twice, and then we're done for today. So step number 1, find the axis of symmetry using x equals negative b over 2a. You now have the vertex's x coordinate. So like when you're drawing a parabola, let me just show you really quick with the pen. Let's say that this is your parabola. Okay, and you just found your equation for your axis of symmetry that drops right here. When you do that, you also have the x coordinate of the vertex, and you can use that to go find the y coordinate. Okay, so that's your next step. And you're going to do that by plugging in your x coordinate to the equation. This probably sounds very abstract right now, but I promise once I show you in real time, it'll make more sense. Then you're going to actually plot your vertex as a coordinate pair. You then have to find 2 other points on the graph on both sides of your vertex. So that would be like finding one right here and finding one right here. I usually do x equals 1. I'll plug that in, and then I'll get my next coordinate for y. Then you're going to reflect that point across your axis of symmetry for your other point, and you're going to create your parabola. So here are your steps. If you want to take a quick picture, I'm going to show you what that really means, okay? All right, here we go. So if I asked you to graph f of x equals x squared minus 6x plus 1, let's do this together. And notice I have the steps down here for you if you needed to reference them again, okay? So step 1, we need to say, all right, a is equal to 1, b is equal to negative 6, c equals 1. I want you guys to do that every single time. Then we need to find the axis of symmetry so that we can draw it in on our graph. We're going to use the formula x equals negative b over 2a. So we're going to plug in, now you got to be very careful, you guys, with your negatives here. We're doing negative b, and I know b is negative 6 over 2 times a. When I simplify negative 6, negative becomes positive, it's just 6, and then 6 divided by 2 is x equals 3. So here's what I've got. My axis of symmetry, the equation, is x equals 3. I can go draw that in on my graph right now. There we go. I also know that for my vertex, I actually have my x coordinate. It's 3. I just need to find my y coordinate so I know where to plot my vertex on my graph. So as I told you in your steps, let's start back with our original equation. And you're going to take out the x value and you're going to plug in 3 because we just found that coordinate right there. So I've got 3 squared minus 6 times 3 plus 1. 3 squared is 9 minus 18 plus 1. 9 minus 18 is a negative 9. And then when you add 1, you get negative 8. So now you've got the coordinates for your vertex. It's 3 and a negative 8. So I'm going to come to my graph. I'm going to go to 3 and then negative 8, and here is my vertex. Now I know right away that this graph will be opening upwards because my leading coefficient is positive, but I need to find a point over here and over here so I can actually create my parabola. To do that, okay, I'm going to just find, all right, I know that x can be 1 over here, so I'm just going to plug in x as 1. So when I do that, I'm going to take out my x value and I'm going to plug in a 1. So I've got 1 squared minus 6 times 1 plus 1. That simplifies to 1 minus 6 plus 1, or sorry, 1 minus 6 plus 3. Why didn't I get 3 there? That's not right. That should be plus 1. 1 minus 6 is a negative 5. Plus 1 is a negative 4. This is looking not good. But actually, this is good because it kind of helps connect or correct some errors. So yay for me. So again, we needed to find another coordinate pair that's not your vertex. So I usually always use x equals 1. To do that, I took out my x and I plugged in my 1. When I simplified, I got 1 minus 6, which is negative 5 plus 1, gives me negative 4. Now I can go plot this point on my graph, and I apologize that I made the mistake, but actually it was a good catch for you guys to see that on screen, because obviously I make simple mistakes too. So I'm going to go to 1, negative 4, and I'm going to plot that point. Here's where you guys can make your lives easy. Notice that this point is 2 away from my axis of symmetry. You can plot the same point on this side. It's like you're reflecting it. So like it's 1, negative 4, and then 5, negative 4. 2 away, 2 away. Then all you have to do is just connect it, and you made your parabola. And that's it. And I know I say that's it, but I know it's a lot of steps, but that's what you did. We found our axis of symmetry. We used that x coordinate of our vertex and plugged it in to find our y, so we got our solidified vertex. Then I need 1 point on one side, and I plugged in x as 1. You could have done x as negative 7, x as 5, whatever, and I got my coordinate pair, and then I just reflected it over so I could connect and create my parabola. Let's do one more together, and then I'll give you your assignment for today. Okay, if I asked you to graph f of x is equal to negative x squared plus 4x plus 3, number one, you know right away that this parabola will be opening downward because your leading coefficient is negative. So I know a will be negative 1, b will be 4, and c will be 3. Okay, that's done. Let's find the axis of symmetry using our formula x is equal to negative b over 2a. So if b is 4, it's a negative b, so we'll make it a negative 4, and then 2 times a. A is negative 1, Okay, so we plug that in here. That gives us -4 over -2, which simplifies to x equals 2, because a negative divided by negative is a positive. Go over to x equals 2, okay, and let's plot our axis of symmetry there. And that's typically always shown with a dotted line. You also know that for your vertex, your x coordinate is going to be 2, and we just need to go find out what that y coordinate is going to be. Okay, so I'm going to take out my x and I'm going to plug in a 2. Well, 2 squared is 4, and again, this negative on the outside will make it a negative. Okay, so it'll be -4 plus 8 plus 3. -4 plus 8 is 4, and then plus another 3 is 7. So we know that y is equal to 7. So your vertex will be at the point 2, 7. Because this is a negative, we know that'll be our maximum point there. That'll be a maximum. It'll be opening downward. We've got our vertex. We now need to go find one point, and then we can reflect it over. So I personally kind of like to stick with x equals 1. That's really easy for me. I like to plug that in. So start by rewriting your equation and plug in, when you see an x, take that out, plug in a 1. Careful though, don't lose this negative. So 1 squared plus 4 times 1 plus 3. This will become a -1 plus 4 plus 3. -1 plus 4 is 3 plus 3 is 6. So my point is at 1, 6. So let's go graph that. I'm going to use a different color to show you. It's at 1, 6. Now this is really easy to reflect it over. This is 1 away, so let's go 1 away here. And then it's going to open downward. And you guys did it. And you could do a few more points if you wanted to, but we don't have to. So let me sum up for you guys what we learned today, because it was quite a lot. We talked about quadratic functions, and the graphs that they create are called parabolas. If your parabolas open upward, okay, if they look like this, that means your leading coefficient will be positive. It'll be greater than 0. It'll also have a vertex that's technically the minimum point, because everything goes up from there. Over here, if a is less than 0, meaning your leading coefficient is negative, that means your parabola is opening downward, and your vertex will be the maximum or the highest point. We know that the line that cuts right in the middle of your graph is called the axis of symmetry. Okay, and before I go there, we also talked about looking at the widths of parabolas, and we can order them from the narrowest to the widest, or the widest to the narrowest. When we think about parabolas, okay, if they have a number that's very small in terms of absolute value, that means it's going to be a wide graph. But the greater the number in absolute value, the narrower it'll be. So like this would be like a 1/3. This would be like a 10. This would be like a -1/7. This would be like a -2. Okay, so the smaller the number, the wider the graph. The formula for an axis of symmetry is -b over 2a, and we can use that to help us not only to find that equation, but it also gives us the x coordinate of our vertex. And finally, we talked about the steps for graphing a quadratic function. We identify what a, b, and c are equal to. We find the axis of symmetry. We use that x coordinate to go find the y coordinate of our vertex, and we plot that vertex. Then we plug in an x value to find a coordinate pair, and we reflect it over. So that was a lot of information. Tomorrow is going to be one of my favorite lessons of algebra, so I'm very excited. But your assignment for today is 9192 Lesson Quiz Online Pearson. I want you to pay very close attention when you're doing problems like this, when you're ordering your parabolas. Okay, so you might want to take a quick picture to help you out. Other than that, you guys are wonderful and awesome and amazing, and have a perfect week.